Hello, my name is Alejandro Salas, and this is a code walkthrough of my linked list project. The way that I wanted to approach this project was by implementing a class like the example we did last week on Thursday. And so this is what I did. I I'll explain the mm, declarations of the class first. So my class is called linked list, and in the private data, I have a node struct. I learned this technique of writing the type def and then making a pointer to this node. And then when you want to reference a new node, then you just reference this name. And this is just to alleviate a little bit of time. I also initialized three node pointers. And moving on to my public data, I have the constructor, and I had the functionality that was required for this assignment. So I have finding the node, I have inserting the node, I have deleting the node, finding the minimum value of the linked list, and finding the max, and finally printing out the linked list. So now that I've explained the declarations, I'll move on to the definitions. So the constructor. The constructor basically um, assigns each node pointer equal to null because that's what we have, a brand new fresh list. And moving on to the inserting function, which adds nodes to the linked list. So we created a new node, sorry, named new node. And this if statement will only run if there's no nodes, um, if there's no nodes once this function runs. So if there is no head pointing to another node, then it would actually initialize the new node made for head. And head and current, if nothing is being pointed to, will equal this new node pointer that we initialized in the class. The data will be the parameter that the user, not the user, this is not the user, this will be random numbers, but the data in which the data of the node will be given by the parameter. The next pointer will be pointing nothing because, I mean, we haven't created that pointer, but actually the current will actually point to this new node, and this is how we can reference this new node. Finding a node, moving on to the function that finds a node in the linked list, has a parameter of this is the user input. It's going to ask for the data they want to find. So I created a node pointer temp equal to head, and this is just for me to be able to traverse through the whole node. And this is what this while loop is doing. This is traversing through the whole node. So while temp is actually pointing to something, this while loop will run. So this if statement will run if the data inside of the nodes in which temp is traversing through, if the data is equal to the data that the user wants to find, then it will return the index value. And if it's not, then temp will be equal to the next pointer, and this while loop will run until this number is found. And if it's not found, then I return -1 because there is no -1 node. It doesn't exist. So I felt like that was an easier way of explaining that. Moving on to the function that deletes nodes. So as fairly similar, I created a node pointer and I made it equal to null, points to anything. This is the pointer that we're going to, this node that we're going to use to actually delete a node. So same thing, I set temp and cur equal to head, so that way I can traverse through the linked list while cur is not equal to null, and while the data inside of these nodes is not the same as the one that we want to delete. So if it's if it actually has nodes in the linked list and the data hasn't been found, then we're going to set temp equal to cur and cur equal to the next um, node. It's going to be pointing to the next node. So this if statement runs if it traverses through the whole list and the data that the user wanted to, the integer that the user wanted to delete wasn't there, then it's going to display that it wasn't actually there, and we're going to delete the pointer for a little bit of um, memory, but I don't think this program will have issues with performance. But if it does traverse through the list and it does find del data, which is the number that the user wants to delete, then it will set that node equal to current. Current will then be pushed up to the next node, and temp next will um, will be equal to the node in which cur is pointing to, and then we delete the middle node. So what we're essentially doing is deleting the middle node and then making the node before it point to the node after the one that we deleted, if that makes any sense. This one I had the most trouble with deleting the node, but I actually grasped the concept, but it's fairly hard to explain. Moving on to a more easier one, the minimum function. This is to find the minimum value inside of the linked list. So I made an variable mini equal to 101. This is because there are no values higher than 100 in this program, and if they are, then um, that data is going to be equal to many. I'll explain. So while cur is pointing to something, so this is basically saying while the linked list is not empty, if the data inside of these nodes is less than many, then we're going to set many equal to that data. So it's going to go through the whole list and check every data, and if that data is smaller than the previous data, then we're going to set that equal to many. And if it's not less if it's not less than that, then we're just going to move on to the next node and check. After that, we return many, and then we can print it. Finding the max function is fairly similar. The only thing that changes is the fact that it's 1 instead of 101, and we're checking if it's greater than, and then we set it equal, and then basically the same thing. Moving on to the printing function. Printing function is fairly similar. The current is equal to head, int equals 1 because we're trying to keep track of how many nodes there are, and while cur is actually pointing to something, so while the list is not empty, then we're going to display the following: the number of node, like the in which they follow, like is it the first node or the like 37th node, and the value that it contains, so the data in which that's in the node. And then we're going to set cur equal to the next node and iterate um, increment, sorry, not iterate, increment this I, so we know how many nodes are in this list. Moving on to the meat and potatoes, the main function, the int. So this is the object I created from my class. These are some variables that I needed to define, and this is a random seed to get random numbers every time. This is for loop. This is what actually creates the list of the nodes. So I created 100 nodes, as you can see right here, and each of them containing a value of of 1 through 100, but it's random. So this basically says that give me a number from 1 to 100 and insert that value into that node. I print the list here, and then I ask a couple questions to the user, which I'll run the code and I'll explain it further. But this is actually I take their decision through choice, and then I have this switch statement that checks for that choice, and I have the UI here and the the functions from the class and how I use them. I'm not really going to be focused in the CPP in this CPP because this video is mostly explaining the functionality of the linked list, and this is more like user interface and stuff like that. This is replayability. This if the user wants to play more with the list, then he enters Y, or he or she enters Y, and then it goes to this label, which will then print the whole functions all again. So I think it will probably make more sense if I run the program, and I'll show you what I mean by all this. So take a second to run. All right. So as we can see, we have a linked list of 100 nodes. Wait, give me a sec. 100 nodes, and each of these nodes is filled with a data, an integer that is random from 1 to 100. As we can see here, they're pretty random numbers. and then it states, now that you have the list of nodes, what do you wish to do? And I added a number for every functionality that was required for the project. So I'll start with the first one, finding a value. So after you press 1, you are presented with the prompt, enter the value in the linked list that you want to find. So let's go through this linked list and let's actually look for a value that we can find. I like 56. Alright, so 56, let's try to look for this value. So if we look for value 56, we should get returned with the node number 8 because that's where it contains that value. So which value do I want to look for? 56. It prints the list again, and it tells the value 56 was found on node number 8. And then it asks you if you want to play again. I'll play again, it prints out the list, and then I'll do it again, just to see, just to ensure that it's not messing around. 6, let's search for 6. So if we search for 6, then it should be node number 86. So let's search for the value 6, and we return, oh, notice, so as we can see, it's actually first found on node number 5. If I want to polish this program, then it would make like it would go through the whole list and not stop on the first node that contains the value, but it just shows the functionality. The second functionality that I want to present was deleting a node. So with the value, which value do you want to delete? So let's go through this list and let's search for a value that we want to delete. Let's delete value 30. So if we delete value 30, this will delete this number of node. 25, node number 25. So we said we wanted to delete 30, right? All right. So which node value do you want to delete? I'll delete 30, and it'll present you with the prompt, the value 30 was successfully deleted. So if we go back to node number 25, then we know that it's changed because, well, the number 30 is not there, and one node is the list is now one node less, so it's 99. I'll continue playing with the list so I can show the min and max. So this is fairly simple. You press 3 to display the minimum value, when the minimum value in this example is 1, and print the list again and search for the maximum value, and the maximum value in this list is 99. Well, that's been my video explaining the code and my thought process behind it. Also going through all the functionality that was required for this project. I hope that it made sense, and I had a lot of fun learning about linked list, and I'm excited to implement this concept into my future programs. Thank you so much for your time and attention.